Think math.
Turn a fraction into a decimal and you get one of two things. 1/4 becomes 0.25 and stops. 1/3 becomes 0.3 repeating and never stops. But here is the odd part. Why does a decimal that neither stops nor repeats never show up? Turning a fraction into a decimal is really just division. Keep dividing and each step hands you a remainder. For 1/7, the remainders run 3, 2, 6, 4, 5, 1. Those remainders are what produce the digits after the point. So watch the remainders and you can see the decimal's fate. The key is how many remainders there can be. Divide by 7 and the remainder is 0 through 6, 7 values in all. With denominator n, the remainder runs from 0 to n minus 1, n values. There are only so many. That single fact decides everything. So there are only 2 roads. If some step divides evenly, the division stops right there. Nothing is left to bring down, so the decimal terminates. And if it never divides evenly? There are only finitely many remainders, but endlessly many steps, so sooner or later, a remainder you have already seen comes back. There is no way around it. Once a remainder repeats, everything after it repeats too. Division looks only at the remainder to decide the next digit. So from that point, the decimal repeats as a whole. That is a repeating decimal. There was never room for a third road. So it comes down to this. There are only finitely many remainders. Divide evenly and you get a terminating decimal. Never divide evenly and you must get a repeating one. Those are the only 2 roads a fraction can take. Next time, why a repeating decimal is still a rational number. How something endless can come back to a fraction. See you there. A sip of math every day here at Think Math.